So we'll take a look at tabular Riemann sums, which is basically the same thing we've been doing, only instead of them giving you a function, they'll give you a table. So it's exactly the same thing, but they give you a table instead of a function. Alright, so example 1, let's say that they give this table. This is a listening check. Color in example 1. Alright, so something to note here. Notice x values are evenly spaced. Notice all the x values are evenly spaced. So it says it goes 2, 4, 6, 8, 10. Who do you appreciate? It goes in 2s. Alright, let's start off with y0, y1, y2, y3, y4, y5. So if we were doing this from the right, it goes from 2 to 12 of whatever the function is. And remember the formula. Actually, let's actually remember this. You can factor out the base. If you remember from the formula when we were doing it from the right, we could factor out the base instead of doing each base times height plus the base times height for the next one and so forth. So factor out the base, which is b minus a over n, and then multiply that by the sum of all the y values except the very first one, because this is from the left. So even without using the formula, you can get the base straight from the table. It's going up in increments of 2. The base is always 2 in this case, right? So you could just say, well, the base is 2, and then I just need to multiply by each of the heights. So I factored out the base, and now I start at y1, which is 13, plus y2, which is 15, and so forth, all the way to yn, which is 3. And then I just work that out. So that's going to be 2 times 54, and that's going to equal 108. If we were to use the formula to find the base, it'll be b minus a, which would be 12 minus 2, which is 10, divided by the number of rectangles, which is 5, which would still give us 2. 10 divided by 5 is 2. So from the left, it's the same thing, the base times the height of each one, only we start all the way at the left, so y0, but we do not do the last one. So we do not do y5 because it's from the left. If you can turn back to your previous notes, you'll see that. So the base, again, is 2, and we can factor it out because it's in all of them. Then y0 is 10, 13, 15, 14, and stop at 9 because we don't include that last one. So that's 2 times 61, which is going to give you 122. So again, you can turn to the previous videos for you to understand why we're not picking the last one. Alright, let's take a look at another example. So we talked about if all the bases are the same. Now we're going to look at an example. What if all the bases are not the same? This is a listening check. Color in the number 23 and 50. So notice that x values are not evenly spaced in this example. The x values are not evenly spaced. And the only difference between the ones that are evenly spaced and the ones that are not is that the ones that are not easily spaced, you can't factor out the base because they're all different. So we could factor it out before because every single rectangle had the same base. But this one you just can't factor it, so you have to do it the long way. You have to find the base times height for each one. So find the base for each rectangle, which is the difference between both sides. So 2, 3, 6, 8, 3, and 1. And then I'm just going to show you that in a graph. So I don't even know what the graph looks like. This is not to scale, I'm just showing you roughly. So I'm going to make space, the base is 2, then 3, then 6, then 8. This is not even to scale. Then 3, then 1. So let's say these are my rectangles. Alright, so we're going to go, let's label y0, y1, y2, y3, y4, y5, y6. Alright, so we're doing this from the left. So it's the base, which is 2, times the height from the left. So it starts at y0. So you see what I was saying from before? It starts at y0. You should actually just know this by now. Then you go 3. The base of the next one is 3. And then it's from the left. And that's what? y1. And then the next base is 6 times the one from the left, which is y2, which is 16. And all I'm doing is putting the value. So that's 8. y3, which is 18. That's 3. Then y4, which is 22. That's 1. And then y5, which is 29. Alright, so you see we can't factor anything out because they're all different. So that's going to be 8 plus 18 plus 96 plus 144. This is a listening check. Color in the answer once we work it out. Plus 66 plus 29, and that's going to give me 361 from the left. Now if I do it from the right, it's the same thing. The bases are all the same. The only difference is now we're coming from the right hand side. So we include everything except the very first one, which is y0. And again, if you return to a previous video, you'll see that, but I'll do it slowly so you can see. So 2 from the right is y1, so that's 6. Then 3 times from the right, which is y2, which is 16. Then 6 from the right, which is y3, which is 18. Then 8 from the right, which is y4, which is 22. Then 3 from the right, which is y5, 29. The last one, 1 times y6, which is 50. Then go ahead and evaluate that. You're going to get 12 plus 48 plus 108 plus 176 plus 87 plus 50, which is going to give me 481. One more thing that I want to mention here, because that's really it, that's all we have, is that if you can take the average of the left and the right, it'll give you an even better approximation. So take the average of two numbers, you add them together and divide by 2. So that's going to give me 421, which is an approximation that's better than both of those. Alright, so that's pretty much all there is just finding the Riemann sum from a table, the same exact thing. So let's practice.